So currently I'll be going through the code overview about this full project. Okay, so all of the code, as I already mentioned, are already available on GitHub. So that is Q&A assistant. Okay, so other than that, let us quickly start going through. So before that, in the earlier video we have already seen how to configure Ollama. So I'll just give you a brief overview about how to check whether Ollama is properly installed in your system or not. Okay, so if you simply type Ollama, then basically you should see this kind of an help which should be popped out for you. Okay, so yeah, that is one thing. So once that is already done, that configuration is already done, and you have already downloaded one of the model, then you are all good to go. Okay, now firstly we'll go through the GitHub page itself. I'll just go through the README file itself. So I've already mentioned that what and all technologies are used in earlier version of the video itself, in the introductory video itself. All right. So yeah, I just wanted to give you a brief understanding about one of the technology which I have mentioned over here, that is called embeddings. Okay, so these embeddings are nothing but basically whenever there is any kind of a text, right? So that text is under the hood converted into vector format, so a kind of a numerical representation, right? So for that numerical representation, we use something called as embedding models. Okay, so that embedding models is what I mean for this specific example, or this specific chatbot, right? For our use case, we have used this specific embedding model. Okay, so yeah, that was one thing. And if you want to simply download that specific embedding model from Ollama, right, you can simply search. Okay, so I'll just tell you how you can download that. So you head on to ollama.com. Then in blog, right here, there is one of the post for embeddings also. So you can directly go to that specific embedding. Embedding models is the blog post. Okay, you can directly reach out to that specific blog post by this specific URL. Okay, and here if you see, right, this is nothing but 23 million parameter model. Okay, and here if you go, then this is all of the embedding models, right, that will be having this specific tag in their name itself. Okay, so yeah, you can always you can download the specific model by simply running the specific command, that is Ollama pull, and then whatever is the model name. Okay, so yeah, that is pretty much it. So how you can download it, that was one thing which I wanted to show you. Now heading on, going back. So now if you want to simply configure, and just get started with it, right? So here are the simple installation steps. You can directly clone the repository, and you can set up your virtual environment, and once it is done, then you can directly download all of your requirements using the pip command. Okay, so once that is done, if you just want to simply get started with your backend working, basically exposing your APIs with fast API, then you simply have to run it the specific uvcon command. So uvcon command will start a local server on your local machine itself, and it will basically expose the APIs, and you can directly use those APIs. Okay, now I will just skip this and all things for a moment. And basically for your front end part, right, you, as I mentioned, that we are using Streamlit, so you can directly run you can directly head on to the front end folder, and you can directly start the Streamlit application. Okay, so here I have just provided some of the details for the exposed APIs. So one of the API is our upload document API. So whatever local files, whatever we have, right, so that you can directly upload from the specific API. And for querying for your document, right, you can directly use the specific query endpoint for querying with LLM. So that basically will infer the vector database under the hood. It will get the relevant chunks, give it to the LLM, and then finally you will get the required output, okay, as an answer. Now Here is a kind of a folder structure which I have made in. So you can always reference this to get a high level overview about what and all things are included in the project. So embeddings, I have provided all of the code. I have segregated all of the things in a different module itself. So my embeddings related code will go inside this embedding folder. This evolution I'll talk later at later stage. um, this specific pre-processing is where our the local documents whatever we will be uploading, right? So that local documents will be uploaded using this specific document loaded.py file, py file utilities which are mentioned inside this specific file. Our text splitter.py file will have all of the chunking related code. So once our document is successfully uploaded, right, we have to chunk that specific code. Okay, so that code will be present over here. Okay, and post that we will be using okay, so this and all are the pre-processing steps, right? So this both the things are basically placed inside this pre-processing folder. Okay, other than that, this Q&A pipeline basically is nothing but our interaction of our basically making of the LangChain chain, right? LangChain chain to infer the LLM model and interact with our local document, right? So all of that code and the relevant utilities are placed inside this LangChain underscore QA.py file, which is inside QA underscore pipeline folder. Okay, and the relevant utilities are placed inside this utilities folder. Okay, other than that, for this specific example we are using Fire's vector database. So all of the code related to that will be placed inside this specific Fire's underscore store.py file. Okay, and other than that, okay, so now I can briefly talk about we have also included different tastes. So once your basically backend is ready and you are all ready to test your APIs, so you can directly use the specific file for evolution part. I have also provided a test example for the specific evolution, how you can use that. So now I'll go over it. So once you expose your basically backend over here, then you can directly run your test of like how it is behaving. So that's what you can you can interact with it. So here I have provided I had okay, I had one of the JSON file. I'll show you that specific JSON file quickly. So inside tastes, okay, I'm sorry, not inside taste, inside source evolution, and here is my taste dataset.json file. So here were the set of the questions which I had asked, and here I had provided my resume itself for the testing part. So here is my resume, and here are my set of the text questions, set of the data set of the test questions. Okay, that is what I have mentioned over here. And basically here I have used one of the approach called as LLM as judge. So I am using LLM as judge as my approach, so wherein I am inferring the LLM itself to rate it whether the predicted output is right or wrong. Okay, so based on that specific prediction, basically that is the approach which we have used. So LLM itself will judge whether my predicted output by an LLM is correct or not. So that is a brief overview about that specific approach. Okay, and based on that we will be having this kind of metrics. I'll just show you. So firstly we will be inferring, once our backend is ready, then we'll be inferring some of the questions like this, and we will be getting some kind of answers for the same. And for the same we will be having something called as judgment score. Okay, so that judgment score will lie between 0 to 1. That is what I have inferred my LLM as judge, basically model 2, and it will always give me some kind of judgment score for each of the question and for each of my prediction. Okay, and then there were 3 of the questions as I showed you, right? So after completion of that specific prediction of those 3 questions by LLM, okay, then basically I will aggregate all of those scores and I will have an average judgment score. and there I have written one of the basically condition wherein if my judgment score is more than 80 percentage, in that case it should pass, right? So here, I mean, in this specific example, my judgment score was already 0.97. I mean, it was roughly around 97 percentage, right? So that was the reason I have passed it. Here you can also calculate various latency. I mean, I have provided an example wherein this average latency also could be calculated. Basically, if there is any fallback, so let's say you did not receive any of the response itself from the LLM, and due to so and so breakages, so all of that also could be recorded. For the for an instance, it was not any, and here the total number of queries is one of the parameter. Okay, so yeah, this was a very short overview about how you can add in your test once you have your backend deployed. Okay, and yeah, maybe, I mean, once your basically backend is all ready, then you can directly move into your front end code. And front end, as I mentioned, that I am using a very simple UI. I mean, I have generated with the Streamlit, directly using the Streamlit itself. Okay, so yeah, this is the brief overview about full, I mean, end-to-end project. Okay, and what else, yeah, I mean, just to mention in, like, this project is under MIT license, so you can modify, you can fork it, and you can, however you want to use it, right? You can all use it, so always feel free to do that. I'm looking forward to have some sort of the future enhancement for this project as well, but I cannot promise I will be doing it or not. I'll be contributing it to not, because there are other priorities also which are set for me for the moment. So, but looking forward to do it. So those were some of the plans what I thought about, and those and all what I have I mean, added in over here. And of course, I mean, if you want to contribute to the specific project, you can always follow this and all steps, and you can always contribute in if you want to. Okay, so yeah, probably that is a brief overview about the project. And here I have also mentioned about the MLOps pipeline, basically the pipeline which I have I have used in. So this follows a very simple, a kind of a reg approach pipeline. Okay, so wherein first thing is data ingestion. So data ingestion is nothing but basically how you can input your PDF or the Word file, right? And how you can feed it, and basically once you feed it, then once that file is feeded, then how you can break it down into smaller chunks. And once it is broken down into smaller chunks, and post that, you can directly embed those small chunks, and those chunks can you can directly save it in your vector database. Okay, just for the better understanding of the reg, right, I will try to show you this specific tutorial from the LangChain itself. Okay, because this is what even I have also referred. Now I don't want to say something like I have learned it by something, and I don't want to it is not that I don't want to expose anything. I'll just show you what and all steps I followed. That is the reason I'm showing you this step. And as I earlier mentioned, that this guys have done a very good job maintaining their documentation, so it is very easy to learn as well. So I'll give you a brief overview about the documentation. You can always go to the documentation and you can read full documentation. Okay, so here, as I mentioned, basically first part comes for the data ingestion part. So data ingestion part is nothing but loading your basically documents, basically splitting it into smaller chunks. And once this chunking is done, you can directly embed all of those chunks into your vectors, right? These are basically mathematical representation of this and all smaller chunks. And once the smaller chunks are ready, you can directly store those smaller chunks into your vector database. Okay, so yeah, that is probably about it. And a high level overview of how an reg architecture works is something like this. So you feed in a question, basically you retrieve it from your vector database. So this retrieval mechanism works something like this. You give a query, you give it to vector database, and then vector database will be searching and basically finding out the most relevant documents based on the chunks itself. And then you will be getting and then basically those and all chunks you will be feeding it to LLM. Okay, and then the LLM will predict the answer based on the question whatever you had asked. Okay, so yeah, that is probably pretty much it about how a normal reg architecture we can follow. Okay, so this is an updated document wherein they have used an lang graph directly to basically follow this rag approach. So lang graph is nothing but a kind of an you can maintain a different states, and you can have a state wise coding, something like this. For example, here if you see, right, here we are starting, and then basically this is a retrieval chain is what they have created. So you are starting, and then you are retrieving, you are having a retrieval logic, and then basically this generation logic is there. So once you retrieve relevant chunks, and then you feed it to your LLM model, and then you predict it. That is what a kind of a graph like structure will be followed using the lang graph, is what you could also do. Okay, so yeah, probably, I mean, I just wanted to give you a high level overview about what is an rag. Okay, so that is what I have given you. From here you can always go through the specific documentation, and you can also refer the conceptual guide if you want to, you know, deep dive into the things and you want to understand everything from scratch, which I would highly recommend you to do that, because once you go through this in our documentation, right, your concepts will be very much clear. That is what I feel. So yeah, that is one thing, that is one part. Now coming back to our project. So this is the data ingestion part. So that was nothing but basically loading our documents, that is PDF or Word file. Okay, then chunking it and saving it into the files vector store database. Okay, so yeah, once that is done, then comes our basically model training part. For this specific project, at the moment I have not done any kind of fine tuning with any of my local LLM models, but that can come, or rather that can go as a future enhancement always. But for the moment, basically loading up our LLM model is one of the part, and basically setting up, basically making our system prompt, and basically making our prompt template ready. All of that part will probably come in over here. Okay, then there is always this model evolution. So basically how our model is basically behaving. Okay, so here, I mean, basically that evaluation part I have shown you one of the approach, right? LLM as judge was one of the approach wherein we use LLM model itself to judge how the performance is. So that is a kind of an autonomous system what we had built, but you can always use this kind of human judgment scoring based thing also. Okay, so yeah, that is one part. And post that, there is this deployment, how we basically once our chain and everything was made, right, once we had done our R&D, then how we can directly deploy it via any of the APIs. So for the moment I have used fast APIs to expose my APIs, right, in backend. So that was one part. Now other than that, you can, I mean, you can always follow this specific CI/CD pipelines also you can build. For the moment I have not built anything, but you can always build your CI/CD pipelines to make everything end to end. So let's say once you do some sort of modification in your code, you can always use the tools out there to, you know, trigger your build pipelines to, you know, run all of this evaluation metrics and all of that part, so that everything would be autonomous, and you can get some kind of report. Or let's say if some of your wrong check-ins have been done, then it would fail at the build step, and that way you can easily identify that something has went wrong, and you can directly go to the code and correct the things. Okay, other than that, yeah, basically this is nothing but the performance monitoring. So again, the latency and the fallback rates is what you can always monitor. You can also build a good high level infrastructure for the same. So yeah, probably that is pretty much it about the MLOps pipeline. um, all right, now I will quickly go to the code itself, and I'll just give you a brief overview about all of the code. So now going firstly towards our backend, so that is our fast API itself. Okay, so now basically we have attached in the logger and everything, so that there will be something called as app logs will be already, I mean, always created whenever you run our project. Okay, so that will be the case. So now okay, let me quickly just I mean compress everything up and at least show you a high level thing how it is all working. So basically here, if you see, right, here there are two endpoints, as I already mentioned. There is an upload endpoint and there is an query endpoint. Okay, So now the specific upload endpoint will be used in order to process our documents. So now for this processing document logic is already mentioned in over here. Now I can always move the specific logic to a different utility class and I can use it. For the instance, I have not done it, but you can, I mean, you are all free to, follow all of that conventions very strictly in order to clean up your code, and keep it tidy in a tidy way. Okay. So yeah, that is one thing. So this is a logic wherein we are ingesting that specific our documents, we are loading the documents, we are splitting our document, and we are creating our vector database. And post that, basically we are okay. So here till here it is only basically creation of the vector database. Okay. And basically creation of vector database is nothing but by the chunks itself whatever we had. So here if you see, right, the chunks we have provided to the vector, I mean the specific vector database algorithm, and basically we have created our vector database. So basically it is all loaded over here like this. Okay. So whenever a new document whatever gets uploaded, right, it will always call this specific function and it will always load the latest, I mean it will always convert all of those documents into vector database. Okay, that is one part. Now the another logic is for the querying the document basically. Okay, so querying the document is nothing but basically our Q&A chain, basically which we have built by the LangChain itself. So basically here first we are setting up the LangChain Q&A, and then basically after that specific setting up logic, then we are directly querying it with the query underscore QS function. Okay, wherein we provide the request.question. So whatever question we get from our front end, right, that we pass it. Along with that we pass in our vector database also. Okay, so once we pass both that, then basically the specific querying logic will, I mean for an instance you can understand it as a magic function which will give you an answer. The magic behind that specific function is nothing but our chain itself, what we have built with our LangChain. So I'll cover it maybe once we go there. Okay, so yeah, so this will give you answer, and basically you are returning it in the JSON format. That is an answer, and basically you are providing an answer dot content. So now why this answer dot content is there? Basically why? Because this answer is having a data type of AI message. Now if I just show you what is an AI message, right? So I guess then it will be even more clearer to you. So AI message LangChain, if I simply type it, right? So if I go here, so here the specific AI message, right? So basically whatever, I mean whenever LLM will be replying me, right, so that reply will be coming in this AI message format, which has the content of, I mean content is one of its parameter, and which will contain all of the textual content. Okay, so that is the reason I am using the specific answer dot content over here. Okay, now probably, yeah, I mean probably that is pretty much it about our backend logic. Okay, high level thing. Now we will go to our front end first. Okay, so front end, as I already mentioned, we are using Streamlit. So this is our Streamlit import, and very simple UI we have built, right? So here you can find out the code for the same. Here we are using a file uploader in order to ingest only PDF and text files for the instance. Okay, so that is what we have provided in, and we have provided a basically text input method in order to fetch in what and all questions you want to ask. And once we get that specific question, then we will always be calling our, I mean we'll be posting it to our backend server. Okay, once we get an probably appropriate response, we will be again pasting it back into our basically answer. Okay, so yeah, that is pretty much it from our front end logic. Nothing much, nothing rocket science over there. Now I would like to cover basically our inner core libraries logic, whatever we have implemented. First, coming to basically embedding model. So as I mentioned that whenever a document file we will be getting, right, so whatever document we will be uploading, those what embedding we are using. So this is the embedding model which we are using for an instance. So here you can directly import this Ollama embeddings from LangChain underscore Ollama. Okay, and then basically you can directly use those embedding, and here I'm simply outputting an embedding model. Okay, now this and all files, okay, you would tell like what is an I mean why to create this kind of segregated files for this and all logic, right? Now the only answer what I have as of now is like you never know like when and all what and all things will be changed. Okay, now let's say you want to provide some kind of an customized logic in your later stage or in your future stage, right? It will always be helpful if you provide, I mean if you segregate all of these files, though this logic for the moment appears to be very simple logic, but in later stage if you want to modify anything, it would be very much easier to modify it in one file and not to modify that full code if you have written everything it in one file. Okay, so yeah, that is one thing. I'll go to the specific evaluation part later, but yeah, I already basically told you like what that evaluation part does for our testing logic. Okay, now talking about our document loader. So as mentioned, our for an instance we are only taking up the text file. We have not yet added in the support for the doc file also. We'll later add it in some, once I get some time. But for an instance, we will be majorly focusing on the PDF file. So this is a loader for our PDF file, and here I have added in a customized logic. So here I'm simply using this specific load function whenever I want to upload any file. Okay, so here I have two approaches for basically this thing. First approach is based on the extension itself. So if in the file path, if I am getting this specific .pdf extension, well and good, I can directly use the specific thing, or else I will be using the specific file type .guess method in order to check what is my file type, and based on the file type whatever comes, right, from therein I can proceed forward and I can load my document, whether basically it is a PDF or a doc file. Okay, document thing. Okay, now talking about the text splitter. So text splitter is nothing but it will split basically the chunk what we say, right? So the chunking logic is what I have what is over here. So as an input I am taking up the documents, and documents is nothing but a kind of the text whatever is loaded, right, from your, let's say from your PDF, right, whatever text comes, so that all of the text will be loaded in a kind of a document. So that is what this document is. Okay, so this document will be getting, and then furthermore we have provided the chunk size, so how much chunk we want to make it and how much overlap of the chunk we want to make. This overlap of chunk and this chunk size and all of those parameters, right, explaining each and everything would be a bit more cumbersome in one video, but if you always you want it, like you can always comment out, I can always make a video for the same. If you want to deeply understand, or I can, you can always research by your own also. It is those are not very high end topic. You will always find some good resources to look in. If you don't have any, you can always comment down below. I'll always be happy to help. Okay, all right, now so yeah, this is our splitting logic basically. Okay, nothing much over here as well. Okay, now coming to our Q&A pipeline. So here our main logic comes in. So here if I show you, so this is our system prompt. Okay, so here I am saying that you are a assistant for question answering task. Use the following piece of required context to answer the question. If you don't know the answer, say that you do not you don't know. Use 3 sentences max, and keep the answer concise. Okay, so here I have already specified what in all my LLM model has to do. So here this is the creativity. Here is where the creativity comes in actually. Like you can always be very creative enough, and you can always instruct your LLM to do specific task, like how you want to do, what you want to do. You can be very much clear about what and all piece of information you want to give, so that your LLM model always gives you the best and the concise output. Okay, probably however customized you want. Okay, so yeah, that is pretty much it. This is my system prompt. Okay, now that system prompt I'll be feeding it to my so here I also imported my check prompt template. Okay, so in my check prompt template I am adding in my that specific system message, and here I have just added in the specific messages placeholder. Now this is nothing but like what and all messages I will be adding in, right, one by one. So all of that messages will go inside this specific part, so that is the reason it has been placed over here. Okay, nothing much. For an instance, the checked Ollama model which I am currently using is Llama 3.2, and temperature I am using it 0. So again, this and all are the hyperparameters with what and all you can tweak in order to um in order to like the Ollama model, or whatever model, whatever LLM model you are using, right? This temperature parameter is nothing but like it can decide how creative it can be. So 0 being very less creative. So I mean, if you want an consistent answer every time, you can keep this specific temperature to be set as 0, and this temperature value lies from 0 to 1. So 0 being the least creative and 1 being the most creative. Okay. So in one, it can try out every time a very different answer it can try to do. For an instance, I have simply kept it 0. You can always tweak those values, and you can check your output for yourself for your custom use case. Okay. Now, here as mentioned, I have also used the LangGraph, the latest APIs itself, in order to build this project. So here I have created a workflow wherein I have basically added in the specific state graph. Okay. And what else? Basically, here I have defined a some of the basically function calls. Okay. So basically here this is nothing but a kind of an basically retrieval mechanism, and basically retrieve documents, and then basically it will call the model, just something like that. Okay. So that's what here this is a very simple part. Here even the retrieval logic is also probably not added in. So here it is simple the model call itself, and here if you see, right, here we are doing nothing much, but simply we are invoking our prompt. Okay. Once we have our prompt invoked, that specific thing we are passing in here, and basically we are invoking our LLM. And once we invoke our LLM, basically whatever output or whatever answer it generates, right, that we are saving it in our messages state itself. Okay. See, now this and all things, probably if you are not understanding, right, then probably you can directly go through the documentation of the LangGraph. Once you go through the documentation of the LangGraph, it will be pretty much more clearer. Okay. Now here, one of the major reason why I wanted to use the LangGraph was I wanted to add in the memory in my this thing as well, so that why I have added in the memory over here, because let's say I have prompted about one of the output. Okay, so let me try to run it and probably show it to you. So I'm already in front end, right? So I can directly let .app.py, and yeah, my backend server is already running. Okay. So now here, let's say I am again providing the specific resume itself. Hi, my name is Jeet. Okay, I'll be simply saying that part. Okay, so it is running still. Okay, nice to meet you, Jeet. Okay, fine. Now I'll ask questions. Like earlier, if you saw, right, in my introductory video, when I was prompting like what are my qualifications, it was saying me like, I don't know about your qualifications, but the file whatever is attached, right, to that I can speak about. Now I can simply prompt what are my qualifications. Okay, so now it is able to clearly make the sense basically from the from Jeet Undevia's profile. This and all are the qualifications. Okay, so that's what. Now it is not hallucinating and telling me like okay, hallucination is again a wrong word over here, that does not fit into the specific context, but basically it is giving us crisp and clear details, right? When I say my, it is able to refer to the Jeet Undevia directly. Okay, so that's what. So that in all memory it can remember. Now let's say if I ask a very simple question, like I can just I can directly ask that what was my name. Okay, So it is directly able to refer that what is my name is. So now it is able to correlate that my name is Jitun Devya. Now this is only possible when whatever questions I have earlier asked this guy, right? So it is able to remember. So that remembering logic is nothing but that comes by this kind of memory saver itself. And LangGraph by default provide this specific in memory saver. So that's what I wanted to use that part, so I have used in here. And in this memory saver part here, in the configuration part, the thread id plays a very important context over here. Okay, so if you will change the thread id, that means your basically the memory for that specific thing is tied. Let's say one of the memory is tied to one of the thread id whatever you provide. If you will use the different thread id, means it will take up the different this thing. Okay, so let's say if you have multiple users, then you can have a different thread id created for each and every for basically creating a different memory for each user, something like that. Okay, now this is nothing but we are setting up a our retriever over here. I mean, for an instance, this is kind of, I mean, for an instance, this is kind of a dead code which I might be modifying it, but I mean, I have just added in so that any of the setup and all steps whatever I wanted, right, that I can directly move it over here in the setup LangChain QA, and then in my query part I can directly only do the querying part. I can move this retrieval logic in the specific setup part, and then I can directly basically use that specific retriever, and I can do all of the configure. I mean, I can do only the invocation part over here. Okay, so probably, yeah, I mean, this all in all, this all configuration of the workflow and whatever I have done, right, that I can directly move to the setup LangChain QA function. Okay, those I had to do, but for some reason I was not able to prioritize it, so that is still remaining, but I'll make sure that I finish it as quickly as possible. Okay, so yeah, the main function is the query QS. So here is where our question comes in, and simply we have to provide in the vector store. For an instance, I am by default using the Llama 2 model. Okay, so that's what I mean. I can always change. We can always change and tweak different models, and we can use it. Okay, so that's what. So first thing what we do is we retrieve the relevant documents from our vector database itself, and once that is done, then we provide whatever chunks we have got to the LLM itself by the graph whatever we have made in over here. Okay, so once that thing is done, basically this is the text document, and this text document goes into this context. So this context is nothing but this specific context what we have provided in our system prompt. Okay, so it goes in our system prompt, and along with that our input messages. So whatever question we will be asking or we will be prompting right from here, so all of that messages will come in over here, and our context will go here, and then it will follow up, and basically it will invoke our LLM, and it will fetch the relevant answer. Okay, and that and all answer I am also printing in my backend also. So let's say whatever things probably we have asked, right, that will go as a human message, and whatever I am getting output from the LLM will go inside the AI message. Okay, something like this. Okay, so yeah, probably that is pretty much it from this LangChain LangChain mechanism or the LangGraph mechanism combinedly what I have for an instance. Okay, talking about the utilities, currently I'm not using, I mean, I'm only using this logger utility, but in future if I have any constants, it can always go into the specific constants, and all of the utility can go inside the specific folder structure. Okay, talking about the vector database, vector database, I mean, just I have made in the helper functions for my basically ease of usage of basically my Fire's vector database. Okay, so that is pretty much it. All of those helper functions are over here. Now I can talk about my testing logic. So my testing logic, I am using PyTest itself. Okay, and in my evaluation logic, as I mentioned, that I will be using decimal parameters. So for an instance like my average judgment score, I mentioned earlier it was 80%, but it is actually 70% which I have set. I can always set it back to 80%, 90%. I mean, you can always tweak around it. Latency also you can always tweak around, like it should be under 2 seconds and all of that part you can always set. Okay, so fallback rate should be less than 20%. I mean, all of this part is quite you can always tweak in. Okay, so yeah, probably that is pretty much it. And the evaluation logic, I think I've already shown you. I'll just again go through it once, so how it looks like. So here I am taking up my, I'm creating my LLM instance. Okay, I'm using again the Llama 3.2 model itself, and here I am specifying that 0 being the completely correct answer, 0 being the completely incorrect answer and 1 being the exactly correct answer, and between that is what you can judge. So here I am providing question, I am providing the predicted answer, and here I am providing the ground truth. Ground truth is nothing but our correct answer basically. Okay, so correct answer is nothing but these are the set of questions and these are the set of expected answers. This expected answer is what is our ground truth. Okay, so yeah, probably all of this will be iterated for, for all these three questions. We will let our model get invoked, and it will give us the predicted answer, and once we get all of these three things, we'll be feeding it to our the specific model. Okay, and we'll let it decide, and we'll let it rate basically from 0 to 1. And once we have that rating, and all for all of the three instances, we'll again pass it back to our basically our test function. And once we have that everything created, we can use this metrics in order to decide whether to pass this test or fail this test. Okay, so yes guys, probably that is pretty much it. This are how the logs will be printed. Okay, this is an example. So yeah, probably this is pretty much it. You can always refer to this requirement.txt file in order to see what and all things I am using. Okay, yeah, one important thing I just wanted to show you, like if you want to do some kind of pre-processing and pre-visualization, if you want to see, right, of your basically text what you are using, you can always use this template. You can always use this and all templates in order to see like what is the correlance of the data. Let's say you are having one of the book, right? So in that book, every content is, you can by plotting this PCA embeddings and basically TSNet, right, you can see how much how the content of how the different content of the books is scattered. Okay, so whether the correlation of the content is more between one content and the other content and all of those matrices, right, you can always plot it first, and then you can always tweak the model, or rather provide a different kind of a system prompt, and all of that tweaking always you can do it. This was one of the graph for odd. I just wanted to see like how my data is scattered between my data what I wanted to process. Okay, and this was a kind of an exploratory analysis, wherein I simply saw like I had one of the book. So I posted that specific book, and I simply saw that what best chunk size I can decide for my use case. So like majority of the chunks were of 2000, right, were of 2000. So I just thought like 2000 would be the best chunk size for that specific use case. So that is how also for the big book or something like big content, if you have, right, you can always perform this and all matrices in order to decide and tweak the values. Okay, so yeah, probably this is pretty much it, like end to end how I have built my project and what is actually exactly there in my project. So yeah, you can just clone it and just give it a try, and probably you can always look at the code and you can get started with your project, however you want. Please feel share to what an ideas you also have. Please feel share to post your ideas, and I would be happy to listen to all of those ideas. And if you have got any other doubts, if you want me to make this kind of videos or this kind of project ideas which you have, and if you want help in that, feel free to connect over LinkedIn or over email. I'll be happy to connect, and we can always work together as well if you have some great project ideas as well. So yeah guys, that is pretty much it from my end. I am also right now a learner. I'm not an expert, or I would not entitle myself as kind of I know everything. I am a learner it was quite new thing what I had learned, so I just wanted to post in. And I just thought like even it could someone of you who even know better and know the better approaches to that, they can also comment that this and all things you can always improve. So that also would be a learning for me as well. So yeah, probably that is pretty much it from my end. So yeah, thank you guys.